Okay, so let's get started. We're going to be taking a look at setting up and working with our traction control tuning feature found in our Link G5 and G4X programming. Now, our traction control is going to be taking a look at wheel speed sensor readings and calculating a percentage of slip between our driven and undriven wheel speeds. This is going to allow a table to be used for traction control that's going to essentially say below a certain percentage of slip, we're not going to have any loss of traction. Above a certain percentage of slip, we're going to find that we're losing traction. And we want the link to intervene and start to retard the ignition timing, start to cut fuel or spark timing, and or reduce our throttle angle if we're drive-by-wire to reduce the torque output so that our percentage of measured slip falls below the acceptable threshold that we are going to program. So it's going to be a closed loop system. It's going to be very effective at reducing your torque and horsepower output out of your engine so that you keep accelerating down the drag strip or in a road course situation, but not completely lay over the engine so that you lose all of your acceleration. Now, it does take some fine tuning on our behalf to get the system to work and function properly. So there isn't going to be just some generic settings that we plug into the software and everything works. We do have to do some fine tuning to it. There are a couple additional important details that we have to make sure are right. I'm going to go over everything from start to finish in this training module so you can see how it's going to work. I'm actually going to be running a demonstration on the engine simulator here on our test bench so that I can slow things down and demonstrate how the actual traction control works so you get a better idea to what to expect when you go ahead and implement it on your vehicle. Okay, so the first thing we're going to take a look at here is an essential critical part of working in the traction control, and that is going to be calculating and setting up our wheel speed sensors. These need to be configured correctly. So let's jump in there and take a look at that in the beginning of the training module. Now, we have covered this in an earlier training module, in an earlier training tutorial in the course. You can always go back into that specific tutorial looking at setting up speed sensors, wheel speed sensors, but we'll just briefly cover that here in the beginning of this tutorial. So let's jump in here from our fuel page and let's go over here to our VSS gear page. And this is where we can define and set up our speed sensors. So first things first, I am a front wheel drive vehicle. So I am setting up my right front and right rear wheel speed. Technically I could set up all the wheel speed sensors, but we only need 2 for the traction control feature to work in its very basic form. So I've set up my right front and my right rear. Now, I have to define under the setup here where it's going to expect a driving and driven wheel speed. So this is going to be important based if you're front or rear wheel drive. Because I'm front wheel drive, my driving wheel speed source is the speed sensor or the wheel speed that's coming from our powertrain. So front wheel drive, I have a transaxle, we have the axles powering the wheels. We're going to be setting it up to our right front speed. The driven wheel speed source is our ground speed, or in this case, our right rear for a front wheel drive car. If you were rear wheel drive, this would be opposite in terms of how we're setting this up. The acceleration source, I'm going to be setting this to the driving wheel speed as to where it's going to look for the vehicle's acceleration. Next, under our wheel speeds, we can see here right front, right rear. My right front is set to digital input 2. And then under the details here, I have pull-up resistor on and the active edge set to falling. I have the same thing here for the right rear. I have a Hall effect style sensor picking up on my factory ABS wheel where I have the teeth on my actual wheel speed. So it's going to be taking a look at each tooth count and it's going to create a pulse, which is what the link's going to count for a speed reading. So that's going to be how I set things up for my vehicle. Now, the next detail that's super important is going to be your calibration value. The calibration value is going to be based on your tire size and the number of teeth that you have for the pickup wheel on your wheel speed source. So in my case, I've already defined these, but we can use our calculator to see what these values should be at to get you really close. Within about 1-2% of a value, you might have to go in and do a manual adjustment, but they'll get you really close for this calibration value. So if we jump in here to our Excel spreadsheet calculator, we're going to find that we have a page labeled speed calculator. Here, we can enter in our tire width in millimeter, our aspect ratio, and our wheel diameter, so the actual rim diameter, 18 inches, so 225, 35, 18. That calculates to a 24.2 total height inches. Then I enter in here the wheel speed teeth. Let's say I have 36 teeth on my pickup for my wheel speed. And then it's going to calculate a value here, the calibration number, 1864. So that's the value we'd put into our software. That will get it calibrated fairly close, usually within 1-2%. I've already done that here for both my front and my rear wheels. We can see that right here. We have our calibration IDs. They're not the same because my front and rear wheels, the tires and the specifically the tires are a little bit different. So we're going to find the calibration ID is a little bit different. The calibration value is different. The next thing we want to do here before we even turn on the traction control is go out and test a rolling calibration when you are in steady state cruising conditions. So the road's flat, you have no loss of traction. You're going to be using your cell phone or another type of GPS reading. You'll drive at a consistent speed. Let's say it's 40 or 50 miles per hour. You want to make sure that's consistent. You'll be then taking a look at your driven and driving wheel speeds. If you're above or below, let's say your GPS is showing 40, you're driving consistent. If your driven or driving wheel speeds aren't matching the GPS speed, you'll adjust your calibration number in either of these boxes so that your driven and driving speeds will be reading the same and they'll be reading relative to that actual GPS reading. Super important. We want to make sure that they're reading the same and that they're calibrated correct. When we're talking about traction control, it's going to be calculating a percentage slip, which is going to be looking at the difference between your driving and driven wheel speeds. So we want to make sure that that's accurate. So in a no traction loss situation, just steady state cruising, these should be identical to each other, which means that the system is calibrated and it's calculating correctly. So I'm going to assume all that's good right now. Let's jump into the next portion here and turn on our traction control so we can talk about some of those settings. There's a lot of little details for the traction control. So let's move over here. Let's use our little right arrow and we're going to go over to our TC window, traction control. And then in here, we're going to go to our traction control window, traction mode. Here, we're going to go ahead and set it to on and turn on and arm our traction control. So let's go here. It's going to say, do you want to zero out the slip threshold table and set it to the default axes values? We're going to say yes right here. We can see a table appears. This is based on gear and rotary trim pot. So that's an excellent way to set this up. We'll talk about this table here a little bit more in depth later in this training tutorial. We also have, taking a look, a bunch of different settings that we can program in here. This is all related to the traction control. Now, what I'm going to do, just so we can kind of see the slip threshold table here, I'm going to set this all to a value of 10. Now, this slip threshold, this is saying that I am going to allow up to a 10% slip measured difference between my driving and driven wheels before we want the traction control to intervene and start to reduce the horsepower and torque output from our engine so that we're staying then below our slip threshold. So it's a pretty simple calculation. And the way that the slip threshold table is used is pretty simple to understand as well. Usually, we're going to have the best acceleration rate out of our vehicle when we're sitting right between 8 to 10% slip. Anything higher than that, it's going to get into too much slip, and we're definitely getting into some wheel spin, and it potentially could hurt us accelerating down the drag strip or around a road course. So usually 8 to 10 is the slip threshold that I'll program in a table like this. That's the maximum slip I'm going to allow. Now we can go and command less slip, but sometimes that can actually hinder the vehicle's acceleration. It kind of depends on the situation in the vehicle and how it's accelerating, but 8 to 10 is a solid target to put into our table here. So we're just going to put a value of 10 for right now. The next thing, if we go in here, we have our traction disabled switch. Right now, we have to select how we want to turn off the traction control. So this is the way we want to bypass the traction control. If you don't want to have a switch to turn on or off traction control, it doesn't matter what you set your disable input to here or your switch type, whether it's a toggle switch or a momentary switch. But just keep that in mind. I am not going to program a disable switch. Generally speaking, when I'm working in traction control, I don't need this disable switch configured and set up if I'm basing the table on a rotary trim pot. The rotary trim pot switch allows us each click position to vary the allowable slip. So we have a ton of different positions we can work with for the rotary trim pot. And then we also have the ability to set this up by gear or any other runtime value in the table. When I'm working with the rotary trim pot, for example, at my 0 click position, let's say it's the first click position, if I set this to a maximum of 500% slip, this essentially calculates or showing we have to exceed a 500% calculated slip. That's such a huge amount that it turns off the traction control. It's essentially our bypass. But then on our first click position.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.